Hello, I'm Phoenix City Council Member Carlos Garcia with District 8. We will never replace in-person teaching, but during these trying times, our children still need to continue to learn. The City of Phoenix is proud to partner with both the Osborn and Roosevelt school districts to bring you PHXTV Classroom Study Hall. Youth and education is a priority for Phoenix. That's why the city is bringing you the study hall to your home during this next hour right here on Phoenix TV. Learning should never stop, so get ready for class. Here's the study hall.
Welcome to our reading corner. My name is Mrs. Fletcher, and I'm a second grade teacher at Clarendon Elementary School in the Osborn School District. I'm really excited to be here with you today because, well, we're doing one of my favorite things, which is sharing reading. And I have some really fun stories and some bonus activities that we get to do together today. So, before we get into all the good stuff, we have to introduce ourselves, and the way you introduce yourself is by saying hello to your friends. So I'm going to teach you one of my favorite hello songs. What's really neat about it is that you get to do it in 3 different languages. That's right. We get to sing it in English, Spanish, while doing American Sign Language. All right. Before I get started and we do our hello song, I will show you the signs we're going to use today. Those are the hand gestures in American Sign Language. We're going to take our hand, make a little, this is called the B hand because that's the letter B, and we're going to make a little salute. We're going to say hello. So this is hello. We're going to say how by taking your high five hands, making them into thumbs up, and twisting them. So how are you? And we're going to take our high five hand. We're going to do I'm fine. 2 more high five hands and bend them a little makes hope. Hope that you are too. We're going to sing this in English and Spanish. And singing is one of the most easy ways to learn language. So let's jump in and say hello to all of our friends. Here we go. Ready? Oh, we'll do it 2 times. Hello, 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 how are you? I'm fine, and I hope that you are too. Again. Hello, 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 how are you? I'm fine, and I hope that you are too. Now let's do it in Spanish. Ready? Here we go. Hola, 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 ¿cómo estás? Muy bien, espero que tú también. Again. Hola, 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 ¿cómo estás? Muy bien, espero que tú también. Yay! That, my friend, is a round of applause. Super fun. Ooh, it's almost reading time. All right, let's do one more thing before we get into our book, and that's going to be a counting song. Now, this is an easy counting song. Really, a really enjoyable counting song. And we do it to the sound and tune of the alphabet song. All right, we're going to count to 21, and it goes like this. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then there's 11, 12, 13, 14, 15, 2, 16, 17, 18 for you, 19, 20, 21, Now our counting song is done. Isn't that great? Let's do that one more time. Now remember, you might have noticed that I'm doing this counting in sign language. If you don't want to count in sign language or you want to count a different way, that's great. Let's just all sing together. Ready? Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then there's 11, 12, 13, 14, 15, 2, 16, 17, 18 for you, 19, 20, 21. Now our counting song is done. Yay! You guys were awesome. You didn't tell me that you were such professionals. All right, super friends. I have one of my favorite books that I want to share with you. And it's about a friend that's really not sure about who he is and just kind of feels sad. Well, it's set in the ocean, one of my favorite places, so it can't be all bad. Let's find out. Let's read the book, The Pout-Pout Fish by Deborah Dyson. And you know who drew these fantastic illustrations? The illustrator, Dan Hanna. Let's check out our book, The Pout-Pout Fish. Here we go. Deep in the water where the fish hang out is a glum, gloomy swimmer with an ever-present pout. There's a pouty fish. I'm a pout-pout fish with a pout-pout face, so I spread the dreary wearies all over the place. Friends, this is the part where you get to join in with me. Every time you see this, I want you to say it. Here we go. Blub, blub, blub. Oh, he's not happy. Along comes a clam with a wide winning grin and a pearl of advice for her pal to take in. Hey, Mr. Fish, with your crosstown frown, don't you think it's time to turn it upside down? Says the fish to his friend. Nice thought, Ms. Clam. I hear what you're saying, but it's just the way I am. I'm a pout-pout fish with a pout-pout face, so I spread the dreary wearies all over the place. Blub, blub, blub. Along comes a jellyfish. He floats through the ocean, his tentacles all trailing in a gentle locomotion. Hey, Mr. Fish, with your daily scaly scowl, I wish you wouldn't greet us with a grimace and a growl. Says the fish to his friend, Mr. Jelly, I agree. I'd like to be more friendly, but it isn't up to me. I'm a pout-pout fish with a pout-pout face, so I spread the dreary wearies all over the place. Blub, blub, blub. Along comes a squid, quite a slender, squiggly sight. She is squirmy, she is squelchy, she is slightly impolite. Hey, Mr. Fish, you kaleidoscope of mope, how about a smile, a little joy, a little hope? Says the fish to his friend. Mrs. Squid, I would try, but I haven't any choice. Take a look, and you'll see why. I'm a pout-pout fish with a pout-pout face, so I spread the dreary wearies all over the place. Blub, blub, blub. Along comes an octopus with 8 great arms, covered on the underside with tiny sucker charms. Hey, Mr. Fish, let me tell it to you straight. Your hokey-pokey soaking is an unattractive trait, says the fish to his friend. Mr. 8, my chum, with a mouth like mine, I am destined to be glum. I'm a pout-pout fish with a pout-pout face, so I spread the dreary wearies all over the place. Blub, blub, blub. Now along comes a fish in a silent silver shimmer. The gang has never seen before this bright and brilliant swimmer. She approaches Mr. Fish, but instead of saying, "Hey," she plants a kiss upon his pout, and then she swims away. Mr. Fish is most astounded. Mr. Fish Mr. Fish is just aghast. He is stone-faced, like a statue. Then he blinks and speaks at last. "My friends," said Mr. Fish, "I should have known it all along. I thought that I was pouty, but it turns out I was wrong. I'm a kiss-kiss fish with a kiss-kiss face for spreading cheery-cheeries all over the place. So I'll smooch, 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 smooch." Yay, Mr. Fish! Aw, he doesn't have to be pouty anymore. That was so fun. I'm so glad it worked out for him. Hey, do you guys want to do a little fun activity before we do our next book? That's right, you get more than one book. All right, so I want to do something that's called roly-poly. Now what roly-poly does is it gets our arms moving and our body moving, and we get to do something fun, and then we come back down and we get to read another book, a fun book. Here we go. Roly-poly. We're going to use our hands, make them into fists, and we're going to twist them. And we're going to use our directions. We're going to go up and down and out and in. Because using directions and practicing these things every day helps us learn how to use our bodies. All right, are you ready? Here we go. Roly-poly, roly-poly, up, up, up. Roly-poly, roly-poly, down, down, down. Roly-poly, roly-poly, out, out, out. Roly-poly, roly-poly, in, in. Roly-poly, roly-poly, clap, clap, clap. Roly-poly, roly-poly, lap, lap, lap. Ready to try it one more time? Okay, get your hands ready. Here we go. Roly-poly, roly-poly, up, up, up. Roly-poly, roly-poly, down, down, down. Roly-poly, roly-poly, out, out, out. Roly-poly, roly-poly, in, in. Roly-poly, roly-poly, clap, clap, clap. Roly-poly, roly-poly, lap, lap, lap. Yay! Round of applause. All right, super friends. I think it's time for one more book. Here we go. I have a special one for you. This one kind of gets you moving, so if you want to stand up and kind of dance along, that's great, because this is a dancing book. That's right, you heard me. Barnyard Dance by Sandra Boyton. Okay. Ooh, here we go. I think we're going to need a beat. Barnyard Dance by Sandra Boynton. Stomp your feet. Clap your hands. Everybody ready for a barnyard dance. Bow to the horse. Bow to the cow. Twirl with the pig if you know how. Bounce with the bunny. Boing, boing. Strut with the duck. Spin with the chickens now. Cluck, cluck, cluck. With a ba and a moo and a cock-a-doodle-doo. Everybody promenade 2 by 2. Prance with the horses and skitter with the mice. Swing with your partner once or twice. Stand with the donkey. Now slide with the sheep. Scramble with the little chickens. Cheep, cheep, cheep. With a neigh and a moo and a cock-a-doodle-doo. Another little promenade 2 by 2. Trot with the turkey and leap with the frog. Take another spin with the barnyard dog. Turn with the cow and a patch of clover. All take a bow and the dance is over. With an oink and a moo and a quack, quack, quack. The dance is done, but we'll be back. Yay! That's a great book. What a fun time. Oh, my friends, I've had so much fun with you today. I can't wait to see what books next week brings. I have plenty, my friends. Well, there's always room for more books. All right, before we do our goodbye song, I just want to share one more activity with you. That's right. Now, this one is kind of a closing, just like we did our opening with our hello song. And this one is our goodbyes. This is our thank you song. So it goes like this. Get your hands out. Did anyone bring their hands with them today? Yes? Yes? Okay, good. Here we go. Ready? It goes like this. My hands say thank you with a clap, clap, clap. My feet say thank you with a tap, tap, tap. Clap, clap, clap. Tap, tap, tap. I roll my hands and say goodbye. Let's try that one more time. Okay? Here we go. Ready? Get your hands out. My hands say thank you with a clap, clap, clap. My feet say thank you with a tap, tap, tap. Clap, clap, clap. Tap, tap, tap. I roll my hands and say goodbye. Yay! So much fun. All right, friends, it is that time. Here's our goodbye song, and we'll do this every time. Okay? Here we go. It has sign language and some singing with it. But instead of hello, we do goodbye. So, and this is the sign for friends and time. You may have seen me do one more time. Okay, so we're going to do goodbye, friends. It's time to say goodbye. Okay. Goodbye, friends. Goodbye, friends. Goodbye, friends. It's time to say goodbye. Let's do that one more time. Okay? Here we go. Goodbye, friends. Goodbye, friends. Goodbye, friends. It's time to say goodbye. Thank you so much, friends, for coming to our corner library. This is Mrs. Fletcher, second grade teacher at Solano Elementary School, saying thank you so much. Keep reading, keep singing, and I will see you next time.
Hi everyone, my name is Mrs. Hughes. I'm a kindergarten teacher for the Roosevelt School District at John F. Kennedy Elementary School. I want to give a shout out to all my Kennedy Colts and especially all of my students that I've had this year. I love you guys and I miss you so much. This is Math Time with Mrs. Hughes. For today's lesson, we're going to be making something, and I'm going to give you a couple clues to see if you can figure out what it is that we're going to make. It's cold. It's sweet and sour, and you make it with lemons. Can you guess what it is that we're gonna make? That's right, we're gonna make some lemonade. Good job. So in order to make our lemonade, we will need 6 lemons, some sugar, water, a pitcher, a juicer, ice cubes, and cups. Let's go check to make sure that I have everything that we need. So I'm trying to figure out if I have enough lemons. I know that when we looked at everything that we need to make the lemonade, it said that we're gonna need 6 lemons. What do you notice about this picture? Do you see any lemons? Yeah, I think I see some lemons too. I see some other fruit that I notice as well. Ooh, it looks like I have some apples. Do we need apples to make lemonade? No, but how many apples do you see? I see 1, 2. I've got 2 apples, but I don't need apples to make lemonade. I also have some oranges, but do we need oranges to make lemonade? No, but how many oranges do I have? How many oranges do I have? 1, 2, 3. I also see some limes. Do you think I might need some limes for my lemonade? No? Well, how many limes do you see? 1, 2, 3, 4, 5, 6, 7, 8. 8 limes. That's awesome, but I don't need limes for lemonade. So it looks like I have some lemons. How many lemons did I need again? 6? Okay, let's count to see if I have enough lemons to make our lemonade. 1, 2, 3, 4, 5. I've got 5 lemons. Is that enough? No? So if I have 5 lemons, but I need 6, how many more lemons do I need in order to have 6? This sounds like an addition equation, maybe. So if I have 5 lemons, we need to figure out how many more we need in order to make 6. So I know that we have 5 lemons plus some more is going to equal 6 lemons, because that's how many we need total to make our lemonade. So let's put 5 in our head and count up until we get to 6. So 5, 6. How many more did we count? Just 1. So how many more lemons are we going to need in order to have 6? Yeah, just 1 more lemon. Let's see if I can find another lemon in order for us to get 6. All right, so here's all my lemons. I'm pretty sure that I counted 6, but I like to make sure to double check so that I don't make any mistakes. Can you help me count how many lemons I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 lemons. Is that 6? No. Do I have too many lemons or not enough lemons? Yeah, I've got too many. How many do I need to take away in order to get 6 lemons? If we're taking something away, that sounds like a subtraction equation. Let's see if we can make a subtraction equation. So with a subtraction equation, we always want to make sure that we're starting with our total amount. So I know that I accidentally grabbed too many lemons and we started with 10 lemons. So my first number in our subtraction equation is going to be 10. Now we need to figure out how many we need to take away in order to get 6. So I know that at the end, we're going to want 6 lemons. So that means that 6 is going to be the last number in our equation. So what can we do to figure out how many lemons we need to take away in order to get 6? Something that we can do is we can put 10 in our heads and count down until we get to 6. Something that's going to help me too is crossing out a lemon each time we count down a number. So let's try that. Let's put 10 in our heads. 10, 9, 8, 7, 6. All right, so I'm at 6. Now we need to count how many lemons we crossed out in order to get to 6. So let's count. 1, 2, 3, 4. We took away 4 lemons in order to get 6. So 10 minus 4 equals 6. Let's double check just to make sure. Let's count how many lemons we didn't cross out. 1, 2, 3, 4, 5, 6. Do we have 6 lemons? Awesome. Whew. Now we're finally able to move on to the next step. You know, all of this counting lemons has got me thinking about a word problem. Do you think you could help me with the word problem real quick before we make our lemonade? Okay, let's see what the word problem says. If I wanted to make 3 pitchers of lemonade, how many lemons would I need? Well, the first thing I need to think about is how many lemons do I need in order to make 1 pitcher? Well, remember we just found out that we need 6 lemons to make 1 pitcher of lemonade. So I'm going to draw a picture first in order to help us solve this problem. The first thing I want to do is make myself 3 sections for each pitcher of lemonade that we're going to make. So I'm going to go ahead and draw 1 line here and 1 line there. Now I'm going to label each section with a number. So 1 pitcher, 2 pitchers, 3 pitchers. So for my first pitcher, I'm going to draw a picture of 6 lemons. 1, 2, 3, 4, 5, 6. We're going to need 6 lemons for our second pitcher too. 1, 2, 3, 4, 5, 6. We're also going to need 6 lemons for our third pitcher. 1, 2, 3, 4, 5, 6. Awesome. So now we've drawn a picture of all of the lemons that we would need in order to make 3 pitchers of lemonade. But are we done yet? Nope, not yet. We have to count every single lemon that we drew in order to find the total number of lemons that we'll need in order to make 3 pitchers of lemonade. Do you think that you can help me count? Awesome. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How many lemons do we need in order to make 3 pitchers of lemonade? 18. Good job. I know that in order to make the number 18, we draw a number 1 and then a number 8 in order to get 18. Now let's see if we can put it in our tens frame. In order to put 18 in our tens frame, I'm going to start at the top left and go over the rows just like I'm reading. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Awesome. Now we represented our 18 lemons with a picture and in a tens frame. Good work, guys. Thanks so much for your help. Now let's get back to making our lemonade. All right, so let's go back and double check and make sure that I have everything that I need. So if you can check for me, do I have everything that I need to make lemonade? We've got the pitcher, the lemons, the sugar, the cups, the ice, and the juicer. It feels like we're missing something. Oh, that's right. We're gonna need some water, aren't we? Well, no worries. I'll just get the water from my sink. Do I have, it feels like something's weird about this picture. Is there something there that shouldn't be? Oh my goodness. What is that? Is that my toothbrush? Oh my gosh. Oh, I'm gonna scribble that out. I must have accidentally left that from this morning. Sorry about that, guys. We don't need a toothbrush to make lemonade. Whew, okay. But so if we go get our water, we have everything else, right? Awesome. All right, let's move on to see what it is, what steps that we're gonna have to take in order to make our lemonade. So, step number 1, we need to cut the lemons in half. Step number 2, we need to juice the lemons. Step number 3, we need to mix in 1 cup of sugar. Step 4, we need to mix in 6 cups of water. Step 5, we just pour our lemonade in cups over ice. And step 6, enjoy our delicious lemonade. So let's go ahead. Let's get started. The first thing that we have to do is cut our lemons in half. So you're gonna need to have a knife. Make sure that whenever you're using a knife that you always have an adult around to help you. Make sure that when you're holding the knife, you hold it on the handle. Are we gonna touch the blade? No, that's sharp. Make sure to keep your fingers away from the sharp blade. You're gonna hold the handle nice and tight, and you're gonna put the lemon down, kind of hold the lemon down so it doesn't move around on you, and you're gonna very carefully cut each lemon into 2 pieces. Cut the lemon in half. Wow, we just cut all of our lemons and now it looks like we have so many more lemons. But we just cut our lemons into 2 pieces. How many pieces do we have now? Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 halves of lemons. For step 2, we need to juice the lemons. Now I'm going to pour the lemon juice into our pitcher. Perfect. For step 3, we need to mix in 1 cup of sugar. I'm gonna give this a little mix. Mix, 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 mix. For step 4, we have to mix in 6 cups of water. This is my 1 cup measuring cup, and we need 6 of them. Do you think that you can help me count? Awesome. 1, 2, 3, Correct. So now we have our 6 cups of water, and I'm just gonna give that a little mix. Make sure to mix up all of the lemon juice, the sugar, and that water that we just put in there. For step 5, we need to put our ice into our cups, and then we're gonna pour our lemonade over the ice. The last thing we have to do is enjoy our awesome lemonade that we just made. Thank you guys so much for your help today. I had such a good time, and I hope that you guys did too. See you next time.
Good morning, students. I'm Michael Roberts, Superintendent of the Osborn School District in Central Phoenix.
And I'm Quentin Boyd, Superintendent of the Roosevelt School District in South Phoenix.
We're pleased to have this partnership with the City of Phoenix to take Phoenix students on a new learning adventure right here on Phoenix TV.
Just because our school buildings are closed doesn't mean the learning stops.
We have the best, most creative teachers from Roosevelt and Osborn school districts on board to provide you with a great learning experience.
Okay, students, that's the bell, so the Phoenix TV Study Hall resumes. Here's your next lesson.
Good morning, everyone. My name is Ms.Damian, and I teach first grade at Irene Lopez. Go Bulls! One interesting fact about me is that I have 5 siblings. A sibling is a brother or a sister. So that means that I have 3 sisters and 2 brothers. Plus me, that's 6 kids. That's a big family. One thing with siblings is that you have to share. Do you have siblings? How many siblings do you have? Wow, that's really interesting. Okay, so today we're going to talk about math related to sharing and siblings. So this is going to be a pretty interesting lesson that you can also use at home. Before we begin, we're going to start talking about our objectives, what we're going to learn today, okay? So let's go ahead and try reading it. I'm going to give you a few seconds to try reading it by yourself. And let's read it together. We will be able to relate counting by tens to add within 100. So this word right here is relate. Relate means how things are connected. So we're going to connect counting by tens to add within 100. Show me thumbs up if you know how to count by tens. Good job. We're also going to use addition and subtraction to help us solve word problems within 100. So here I see that the word problems is highlighted in orange. That means it must be really important. A lot of students are having a hard time understanding what word problems are. So let me just quickly tell you a little idea to help you remember. My turn and then your turn, okay? A word problem is a story using numbers. So simply, a word problem is just going to be a story where I use numbers. Okay, my turn again. A word problem is a story using numbers. Your turn. Good job. So let's do it together. So our brain remembers when we do it all the time, and we use our hands to move things too, okay? So a word problem is a story using numbers. Good. So today we're going to do 2 things. We're going to relate counting by tens to add within 100, and then we're going to use adding and subtracting to help us solve word problems. Let us begin. Remember, I mentioned that I have 5 siblings. I have to always share with my siblings when I was little. So let's pretend that I was little and I bought a candy bag. Here's my candy bag. I love candy. Do you love candy? What kind of candy is your favorite? Ooh, those are delicious. I really love gummy bears, but here are just some little sweet candies that I drew. So this is the candies that I had to share with my sister. She really wanted some candies, and you know, because I love to help and encourage, I decided to share some candies with her. The problem is, the word problem is that Ms.Damian had some candies. She gave her sister some. How many did they have all together? The problem or the issue I have with this is that I don't know how many Ms.Damian had. I don't know how much her sister had. I see it in a picture, but what can I do to help me find how many they had? I had or she had. Think about it. What can I do? I need to figure out how many we had all together. So I'm gonna let you think. And then go ahead and tell me, what do you think we should do? Let me hear it. I hear some students saying that we can count by twos. Some of you guys saying we can just count them all. Okay, let's try counting them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh my goodness, I am so confused because I don't know if I counted this one. I'm going too fast, and maybe that's not an efficient strategy. Efficient means we don't waste time. So, going back to what we were supposed to work on, our objective, we need to relate or connect counting by tens. Maybe we can group them into tens. Let's see. I'm going to put a dot on each one until I can make a 10. That's going to help me count by tens. Do you know how to count by tens? Okay, let's try it. Show me how to count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Good. Some of you guys learned a song in your classroom. So if you know it, perfect. Use a song to help you skip count by tens. I just learned it by 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I'm going to just group these to help me count by tens. Let's see. Oh, let me use a different marker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I'm just going to group all the ones that I put a dot on to show that they are 10. Okay, now look at this group that's left over. Can I make a 10 with that? Thumbs up, yes. Thumbs down, no. I do think there's enough to make a 10, so let me just double check. Count with me and tell me when to stop if you count by, or if you counted 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is definitely enough for 10. Again, thumbs up or thumbs down if there's enough for 10. Of course, there's not enough for 10. How many do you see right now? 1, 2, 3, tell me. Beautiful, we only see 3. So we have 10, 20. Oh wait, before we do that, let me remind you, sometimes we have to count them all together. Now we count by tens and then we count by ones. In my classroom, we say first you count by tens, then you count by ones. First you count by tens, then you count by ones. And that's going to help you remember, what do you count first? Well, first you count by tens, then you count by ones. 10, 20, 21, 22, 23. What number is it? Good. Write it in the sky. 23. 23 has two groups of 10, 2 tens, and 3 ones. Okay, Sabrina, if you wrote 23 correctly in the sky, good job. Now, this is Ms. Damian's side. My sister had this many. How many did my sister have? What should be the first thing we do? Correct. We should group them first to see if we have any 10s. Can you tell me yes or can you tell me no? Let's check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There is enough to make a group of 10. Now, show me. Yes, there's enough to make another group of 10, or no, there's not enough to make another group of 10. What do you think? There's definitely not enough to make a group of 10. So, now we get to count. First you count by 10s, then you count by 1s. First you count by 10s, then you count by 1s. Let's count by 10s. 10, 20. Nope, stop, try again. We need to count by 10s and then we need to count by 1s. 10, 11, 12, 13. Correct. Show me how to write 13 in the sky. 1 10, one group of 10, and 3 1s. Nice job. Okay, now let me tell you the word problem again, my story with numbers. Ms.Damian had 23 candies, and she gave her sister 13 candies. How many candies did they have all together? Well, when you say all together, is that adding or subtracting? All together. Another song that we do in our classroom is plus means you put together, minus means you take away. Plus, and I make a plus with my fingers. Plus means you put together, and then I make a minus with my fingers. Minus means you take away. My turn. Plus means you put together, minus means you take away. Your turn. Good job. So if we need to put them together, which symbol will I use? Plus or minus? We would use plus. Beautiful. Plus. Let's make it into an equation by adding an equal sign. 23 plus 13 equals, we don't know what that is yet. We need to solve it. So say it with me. 23 plus 13 equals, Now, here's a strategy you can use. If you have a picture, like I do, you can use the pictures in the groups of 10 to help you. I can count the groups of 10 first all together. So all together, I see 10, 20, 30. Now I count by ones, 31, 32, 33, 34, 35, 36. The total is, or the sum is, 36. Now, 36 candies is what we had all together. Now, sometimes you will not have the sketch or the diagram in front of you. Some students will decide, okay, well, let me draw 23 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that's going to take a long time. Instead, teachers have been showing you, or some teachers show you, that you can use your place value blocks using 10s and 1s. The 10s look like this, and the 1s look like this. When you draw it, the 10s sometimes just look like one straight line. And it's called 10s. Why? Why do you think it's called 10s? Nice job. It's called 10s because there are 10 in one block. Of course, why do you think these are called 1s? 1s because there's only 1. So let's try using our 10s and 1s to help us in case we didn't have this picture. Let's use green and red, green for 10s and red for 1s. So here, first you count by 10s and then you count by 1s. How many 10s do you see? I see 2 10s. So I draw 1 10, 2 tenths. How many ones do you see? I see 3 ones. 1, 2, 3 ones. Now, let's look at the other one. How many tenths do you see? I see 1 tenth. How many ones do you see? I see 3 ones, correct. Oops, I gotta use red. 1, 2, 3. Now, first you count by tens, then you count by ones. If I was to put the tens together, how many tens will I see? 1, 2, 3. 3 tens. How many ones will I see? 1, 2, 3, 4, 5, 6. 6 ones. So my 2-digit answer for 23 plus 13 will be 36. 3 tens and 6 ones. Thumbs up if you understand what's happening. We're drawing tens and ones to help us add 2-digit numbers within 100. And we can use our skip counting by tens to help us. Watch this again. 10, 20, 30, 31, 32, 33, 34, 35, 36. Beautiful job. Now that we've tried it with Ms.Damian, I want you to try it with at home so you can practice and learn from home. What I want you to do is I want you to quickly grab a paper, or if you have one in front of you, perfect. We need to practice at least one together. So let me go ahead and pick this problem right here. I'm going to give you a challenging one. Not sure if you can see it correctly, but I will write it on my paper. Let's use this color. This is the problem, and write it with me if you have a paper. 37 plus 40 equals, Give you a few seconds to write that down. Good. Now what's the first step we do again? We look at the 10, and we're going to try drawing it using tens and ones. So the first step we do, some of us need it, so we're going to label tens and ones. Tens and ones, tens and ones. We get to draw 3 tens. How many ones will I need? 1, 2, 3, tell me. Good job. I heard students saying 7 ones. 1, 2, 3, 4, 5, 6, 7. Now, let's add 40. 40 has, tell me, how many tens and ones? Tens and ones. 4 tens and 0 ones. Great job. So we have 4 tens. 1, 2, 3, 4. 0 ones. Do I need to draw anything? No, we don't draw anything. If it's 0 ones, that means it's nothing. So we need to put them together now. Let us use our other marker again. And we need to put the tens because first we count by tens, then we count by ones. How many tens do you see? 1 10, 2 tens, 3 tens, 4 tens, 5 tens, 6 tens, 7 tens. So I'm going to put 7 tens, 7 in the tens place. And then how many ones do we see? Well, I see none here. So how many ones are there? There should be 7 ones. Beautiful job. So let's say the equation. 37 plus 40 equals 77. Good job. That was one practice we had together. What I want you to do now is I'm going to challenge you. You get to practice at home with a sibling or a parent or somebody who is older than you. Remember that my focus was being with the sibling. I had to share. So I'm going to challenge you to share with your siblings. You can try getting some candies. Maybe if you don't have candies, how about you go outside and collect some rocks? You collect some rocks and your sibling collects some rocks. And then you can challenge your brain to use addition and subtraction to help you solve word problems. Maybe you can add them together. Maybe you can subtract. It's up to you, but I want you to practice so that you can learn more and your brain can get smarter, okay? So I want you to work hard so you can try this at home. Remember, you want to relate it to counting by tens to help you add within 100, and you want to use adding and subtracting to help you solve word problems. You can do it.
Hi, and welcome to our class. My name is Mrs. Juvera. I am a third grade teacher at Maxine O School. Go Wildcats! I miss all of you guys. Today we are going to be doing math, but before we get started, I actually wanted to start with something that you guys know, and I want to sing a song. Some of you know me and some of you don't, but I know that all of you know this song. And you're probably thinking, well, we just met her. How does she know that we all know the song? Trust me, it doesn't have anything to do directly with math, but I promise you I'll tie it all in very soon. So we are going to actually sing the happy birthday song. So warm up your vocal cords, and whenever you're ready, we're gonna count and sing on 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday, dear somebody. Happy birthday to you. Now, we're going to take that song that you guys know so well, and we are actually going to use it and change it just a little bit. Big thank you to Miss Clarendon Harley, who is a 4th and 5th grade teacher. She took this song and changed it so that we can use it to do our skip counting with sixes. So we're going to use the same happy birthday tune, but we're going to change it with numbers. This first time, I only want you to listen. What do I want you to do? That's right, just listen. I'm going to sing it, and after I'm done, then the next time we will sing it together. Are you ready? Okay. 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. Pretty easy, right? So we're going to take that happy birthday song that we know so well, and we're going to do a little twist, and we're going to change it to sing with our sixes. Are you ready? We're just going to follow the numbers right on the page with me. 1, 2, 3. 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. Great job. And in my classroom, whenever anybody does anything well, we're going to celebrate them. So your celebration cheer today, I'll ask you to do it time to time. Whenever you do something well, I'm going to say kiss your brain and kiss your heart. So thank you for singing. I would like you to kiss your brain and kiss your heart. Now let's go back to that song we just sang. Why is this song important? How are these numbers put into this song helpful, and how are they going to help us? Hold on to that thought. We're going to be digging right into it. Let's start off with a math problem. I'm sure that all of you guys have the opportunity to work on word problems when you're in school, and today you're going to do one with me. But this time, I only want you to watch me. What do I want you to do? That's right, just watch me. I'm going to show you, and then we're going to take these skills later on to work on some multiplication. So here we go. Here is my problem. Let me pick a different color. Jerry takes 3 jugs of water to her backyard for a soccer game with her family. Each jug contains 6 liters of water. How many liters of water does Jerry bring? There's many steps that can be taken, but I like to use 3 steps with my students. And those steps are, first we're going to read it, then we're going to draw it, and lastly we are going to write it. So reading it, we're going to go back and look for any important information that can help us solve figuring out how much water Jerry brings. So let's start with the question. I always start by boxing the question word. The question word is how. Let's box the question word how. The next thing I'm going to do is I'm going to circle what the question is about. This question is actually about the liters of water. So I'm going to circle liters, and then I'm going to circle water. The last thing I'm going to do is I'm going to put a wavy line underneath what they want to know about the liters of water, right? So they want to know how much Jerry brings. All right, time for us to go back now. Let's look into the equation, the problem. Look for any information that's going to help us figure out how much Jerry brings. So we're looking for numbers, we're looking for anything that has anything to do with water or containers, and all of that information, we're going to take it and help us solve, okay? So at the very top it says Jerry takes 3 jugs of water. That's important. I know that the question is about water. I'm going to underline 3 jugs of water. Now, it's asking about liters. So now I want to go back and look for something that has to do with liters. Each jug contains 6 liters of water. I'm going to underline 6 liters of water. Those 2 pieces of information, the 3 jugs and the 6 liters in each jug, is what is going to help us solve how much water she brings total. So I want to use 2 different strategies. Just like somebody that builds a house, I don't know if you have this in your schema or your background knowledge, but I've never seen anybody build a house with just one tool. They have multiple tools. They need hammers, but they also need other materials besides hammers. When you are solving math, you need other tools to use as well. So I'm going to give you 2 strategies. The first strategy is going to be an array. The second strategy is going to be a tape diagram. We're going to use an array to model our problem and a tape diagram as well. So let's go down and we are going to use those 2 numbers. So the first number we saw was 3. The second number we saw was 6. I could add the numbers over and over again, but multiplication is the same thing as repeated addition. So instead of adding, I'm going to choose to multiply. 3 times 6. The way that I'm going to draw an array is another way of saying nice, neat, organized. So I'm going to do rows. They're going to go top to bottom, and then I'm going to do the number in each row that goes side to side. So since she has 3 jugs, I'm going to make 3 rows or 3 groups. 1, 2, 3. Each jug has 6 liters of water inside. That's going to be my number that goes across, or the number in each row. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. When I write my equation, 3 represents the number of groups. 6 represents the number in each group. In order to solve and find our product or our answer, I'm going to count it, but I'm going to keep track of my counting just so I don't mess up on my answer. So I know there's 6 in this row, and we sang a song, right? We did the happy birthday song. We're going to use that right now to help us solve. We could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would take a lot longer. We're going to use the happy birthday song, and it's going to help us be more efficient when we count. So that's 6, 12, 18, and stop. We don't need to count any further because we only have the 3 groups. Our product is 18. That was one strategy, one tool for your tool belt to help you build your house. Now let's do another one. A tape diagram is like a piece of tape, except we're going to use that large piece of tape and we're going to put information inside. So let's start off by drawing what looks like a great big piece of tape. Don't make fun of my drawings. They don't need to be perfect. Now, let's go back to our problem. 3 times 6. I need 3 groups. How we did our groups over here, we're going to separate our tape diagram into 3 parts. So that's 1, 2, 3. Those are Jerry's 3 jugs. Inside of the tape diagram, I'm going to do 6 bubbles, dots, stars. I wouldn't get too fancy. You don't want to take too much time drawing stars. We want to just use this skill to help us get to our answer. So 1, 2, 3, 4, 5, 6. Keep going. 1, 2, 3, 4, 5, 6. Almost done. 1, 2, 3, 4, 5, and 6. Now, we're going to use our happy birthday song one more time. I know that you're watching me, but I'd like you to sing the song. So, 6, 12, 18, and stop. Great job. Let's go back to our equation. Both of these equations are the same for both of our strategies. You have 2 different tools to use now. You have an array and you have a tape diagram to help you build your house or solve math. Let's go back. We drew 2 strategies. Now let's write it out. Jerry brings liters of water. She has 3 jugs or containers and 6 liters in each. 3 times 6 equals 18. Jerry brings 18 liters of water to her backyard for a soccer game. I'm sure she can use it with this Arizona weather. It's pretty hot outside. Now let's work on something together. Here is your big question. A little hard to see. I want to know, is 3 times 6 the same thing as 6 times 3? You may or may not have heard of the commutative property. We're going to learn about what the commutative property is and how it helps us to figure this out. So, we're going to first use a strategy. You have 2, tape diagram or an array. Pick whichever works best for you. That is how you are going to show your work. So for this first one, I'm going to pick the one that I like, and I really, really like the array. So I'm going to use the array. I need to first show 3 groups. So when I draw it here, I want you to draw it at home. 1, 2, 3. 3 groups. Our second number or factor tells us how many are in each group. I need 6, so we're going to put 6 going across. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And the last one, 2, 3, 4, 5, and 6. We know our skip counting song. We're going to use it again. Are you ready? 6, 12, 18, stop. Now let's move to our next one. This time the numbers are the same, but they've switched places. So instead of having 3 rows or 3 groups, this time we have 6. So let's go ahead and draw our 6 groups. Remember, you can use whichever strategy works best for you. I'm going to double check. 1, 2, 3, 4, 5, and 6. And in each row this time going across, I'm going to have 3. So that is 1, 2, 3, 1, 2, 3, all the way down. We want to make sure we have the same number in each row. Our last step is we want to double check and count and make sure that we can keep track of our counting so that we have the correct answer in the end. going back to, I want to know if they're really the same. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Let's go back to that question. Is 3 times 6 the same thing as 6 times 3? Well, 3 times 6 equaled 18, and 6 times 3 equals 18. And the reason for that is the commutative property. The commutative property says you can have 2 numbers or factors. It's only when you multiply them. If you multiply an equation, it has the same 2 numbers and they switch places, your answer or product will always be the same. So the answer is yes. And the reason why is because the commutative property. 2 factors, same numbers, switch places, same answer. You got it. Hold on to it. And I want to celebrate you. Thanks for working with me and singing. Kiss your brain and kiss your heart. By now, you're probably sitting in your living room with your families or your brother or your sister, grandma, grandpa, whoever it is. I want you to do it with them. So this one, I changed it up just a little bit on you. So instead of saying times, I put 2 numbers and words next to each other. So we have 5 eighths equals 8 fives. Whenever you see numbers written as words or vice versa, it's the same thing as saying times. So this means 5 times 8, and this means 8 times 5. I want you to remember to use a strategy and show your work. So which strategy are you choosing to use? Are you going to use that tape diagram that looks like a great big piece of tape and separate it into your groups and the number in each group? Or are you going to use an array? Nice, equal, neat groups. Don't focus on your drawing. Focus on your strategy. Think about those tools for your tool belt. Give you a second to think. I know you picked the right one that's best for you. I'm going to use the tape diagram. Remember, we want to show our work. I want to show it for both problems. So for my 5 times 8, I'm going to use a tape diagram this time. 1 tape diagram on this side and 1 tape diagram on this side. Our goal is to prove that both of them are equal. So I'm going to have 5 groups in my first one. 1, 2, 3, 4, 5. Don't focus on my drawing. And 8 groups on this side. 2, 4, and 8. Inside of each group, I'm going to use the next number. So I need 8 inside of each of these and 5 inside of each of these. So 1, 2, 3, 4, 5, 6, 7, 8. Keep counting, and a good strategy, you can add the number at the end as soon as you are done. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. My next step is to count how much are inside, and I'm going to keep track the same way I did. This time you're going to write it at the bottom of your tape diagram. So that's 8, 9, 10, 11, 12, 13, 14, 15, 16. I have lots more songs to teach you later on. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. I know that this equation equals 40. Now I want you to prove that the other side equals 40 as well. I'm not going to do it because I know you can do it at home, and I want to go ahead and celebrate you while you are working. Keep up the good work. Let's talk about what we did today. You used 2 strategies, gain 2 tools for your tool belt to solve multiplication equations. You now know how to use the arrays with your equal groups and your equal number in each group, and you know how to use the tape diagram. Great big piece of tape put into equal parts and the numbers inside each. We used our happy birthday song for skip counting with our 6s. You have homework. Use a strategy, pick one of those tools from your tool belt, and I want you to solve that 5 8s equals 8 5s. Finish that one and show it to your family. Make sure you explain how you know the commutative property gives you the same product or answer. And then I challenge you to work on 6 9s equals 9 6s. I miss you guys so much, and I can't wait to see you all soon. See you later.
Hello, Osborn School District students. Welcome, Clarendon Cougars, Longview Lancers, and sorry about that mishap, Solano Tigers. It's Mr. Meza here. I teach 5th grade at Clarendon Elementary. And this week, week 4 for distance learning, I'm going to be focusing on multiplying fractions. But before we get into that, we'd like to get to know fun facts about our fellow Osborn School District teachers, especially our 5th grade ones, because we don't know everybody so well. So a fun fact about me is that I have traveled to 56 countries around the world. So you have to understand that where I come from, I usually like to travel. And so this has been hard, but we're going to get through this together. So let's dig in. In this week, a couple of things. Previously, you have multiplied decimals, divided decimals, and done decimal fractions. But this week, we're going to be focusing on 3 big ideas. So this lesson, it has going to have 3 different models, but it requires you, if you need a multiplication facts chart, please grab one or find one online so that you can do the Learn Zillion lessons effectively. So you need to know your multiplication facts. Most of them are from 1 to 12, as you've been doing with your teachers at your school. We're going to learn about fractions, unit fractions, and non-unit fractions, and then some strategies for converting. And don't worry if you don't understand what that is, because I'm going to take all the necessary steps to take you through everything by modeling what I'm thinking and how to solve these problems. So let's see what our weekly objectives are. Students will be able to first multiply a whole number by a fraction. So that's the first step, and that's going to be one of my first models. Then students will be able to multiply fraction by fraction, and I'm also going to model that. And then lastly, probably the most complex step, but still we're going to slow it down and take it apart. Students will be able to multiply a mixed number by a fraction. Those are 3 big concepts, and they all build on each other. So please make sure that you watch the videos in order and that you follow my models in order to be a very effective and proficient with this. So let's dig in. Okay, for example 1, we're going to do the first objective. Students will be able to multiply a whole number by a fraction. Example 1. I'm going to take a whole number and multiply it by a fraction. First step, what I need to do, you might remember, is that 5 is the same as 5 over 1, which is a whole number. So you want 2 fractions in order to be able to multiply them. So then you have 4 parts and they're matching. So now you can bring down your fraction. And now you simply have to multiply across. Multiply across. This will equal 5 times 1, which is 5, and 1 times 3, which is 3. However, some of you might remember that when I have the numerator that's bigger than the denominator, that's called an improper fraction. So what I have to do is I have to take the numerator and divide it by the denominator. There I can see that 3 goes into 5 one time, and there's a remainder of 2, and then we keep the denominator, which is 3. So I end up with a final answer of 1 2/3. Here you can see that my answer that I started with was just 5 wholes, and I ended up with less than 5 wholes, because anytime you multiply a whole number by a fraction, you're going to end up less than what you started with. So my answer for multiplying whole number by a fraction, here are the steps. You're able to review them, and you end up with 1 2/3. That's example 1. Okay, for example number 2, we are going to do fraction by fraction. This is a more simplified way, and there's 2 types of fractions that you're going to be seeing in your Learn Zillion videos. First is what we call a unit fraction, which is a 1 in the numerator. For example, 1/2, 1/3, 1/4, etc. So when you multiply a unit fraction, you find a fraction that has a 1 in the numerator. So 1/5 times 1/4. And just as in the previous example, you just multiply across, and you get 1 times 1 is 1. 5 times 4 is 20. Your answer, 1/20. The other type of fraction by fraction that you're going to see is a non-unit fraction, which means just the opposite of unit fraction, something that in the numerator is everything but a 1. For example, 2/3, 4/5, 7/10. Those are just examples, etc. But in both examples, you do the exact same thing. You just multiply the fraction. I'm going to take one of these 2 examples here. I'm going to take this one, and I'm going to multiply them. 2/3 multiplied by 4/5. Again, we just multiply across. 2 times 4 is 8, and 3 times 5 is 15. In these lessons, I will tell you, for most of the examples, it does not ask you to simplify or reduce. They just want you to enhance the skill of knowing how to multiply fraction by fraction. Later in the lessons, you will find that you will have to reduce or simplify, but the next teacher will let you know when that's going to happen. So that's example number 2. Okay, so for our last example, example number 3, we are going to take a mixed number, 3 1/4, multiplied by a fraction, 2/3. Now pay close attention, because this is different than our last 2 examples. Here we have a whole number. This is the whole number. I'm going to color the different parts. The denominator and the numerator. So in order to multiply a mixed number by a fraction, you first are going to have to turn this into a regular fraction. So what you're going to do is you're going to multiply the denominator times the whole number. You're multiplying there, and then you are adding addition to get your numerator. So what that looks like is 4 times 3, which is 12, and then you're adding 1, which is 13, and you keep the denominator the same. So you end up with 13/4. 13/4 is an improper fraction, and now you're going to bring down the fraction you were multiplying with. So let's rewrite it all together. 13/4 multiplied by 2/3, which gives us, and yes, I don't expect you to know your 13, so I'm going to do the multiplication up here. 13 multiplied by 2 is going to give me 3 times 2, which is 6, and 2 times the tens place, which is 2, 26. 26/12. Again, when the number above is higher than the numerator, which is 26 is bigger than 12, this you have to divide by 12. So you have to divide 26 by 12. And I know that 12 times 2 is 24. So I know that 12 goes into 26 2 times. And then there's remaining, because 12 times 2 is 24, and this is 26, there's 2 12s left over. And that is your final answer. And some of you might have figured out that 2 12s could be reduced, but again, in these videos, they don't ask you to reduce or simplify until later in the lesson. So 2 and 2 12s would be your answer. Okay, I know that was a lot of information, but just to debrief, we learned 3 different forms of how to multiply fractions. We started with a whole number by a fraction by a fraction, and we ended with a mixed number by a fraction. I know it's a lot of information, and again, we have said before that this is not meant to be done in one sitting, so please remember to break it up in chunks if you need to. Thank you for listening, and thank you for being attentive and doing your work. A reminder, you have opportunities to solve. So I referred to this earlier. You're going to do these in on the Google Sites through LearnZillion, and also you have choices on your choice board.
Hi, I'm Mr. Stacey. I'm a math teacher at Osborn Middle School, and I have a question for you. Do you like to play with your food? If you're like me, you might have answered yes. Now, I know that there's a lot of places that you're not supposed to play with your food. Obviously, you don't play with your food at school. Obviously, you don't play with your food at a restaurant. And you know, often, you don't play with your food at home. But sometimes, just sometimes, you get permission to play with your food. And right now, I'm about to give you permission to do that. And we're going to use it to solve equations. Now, if you're like me, then you probably like games. I'm a really big gamer. I like video games, I like board games, I like playing games outside. I just like games. They're puzzles, and every single one of them can be solved. You can win every game. It's just a matter of figuring out how to win. I look at math the exact same way. How can I make math into a game that I can win? And so what we're going to do today is I've created a little puzzle using, you might notice I've got a bowl of Hershey's Kisses and Skittles and some plates and things here. And we're going to make this into a puzzle, and we're going to try to beat the puzzle. Now, if we do this right, by the end of this, you'll be able to solve equations without even touching paper. All you need is a couple plates, some candy, 2 different types of candy. It doesn't even need to be candy. Today I'm using Hershey's Kisses and Skittles. You will notice I'm only using silver Hershey's Kisses, those are positives, and I'm only using green and yellow Skittles, those are positives as well. Next week we'll get into a little bit more depth with how could we incorporate negatives. This week, just positives. But that's it. Hershey's Kisses, Skittles, and we're good to go. So, I'm going to be explaining how to do 3 different equations. The first equation is going to be pretty simple. Most of you have probably seen maybe even this exact equation. The second one is something that's a little bit more advanced, more kind of in the end of 7th grade, 8th grade level. And the third one just incorporates a strategy that you've definitely heard of, and we're going to use it to solve an equation. You might think these are kind of easy. Yeah, we have to start at the beginning. If you start a video game, you don't just like jump in and you're immediately really good at it. You have to practice. Or if you play soccer, you're not just able to do a rainbow. You're not able to flip the ball over your head the first day you play. You have to practice. You have to start with basics and get a bit more challenging every time. So that's what we're going to do. We're going to start with some basics and then we'll move into some more advanced stuff next week. So our first equation is 3x plus 4 equals 25. 3x plus 4 equals 25. Now we have a few pieces to that equation. We have to remember 3x, we've got a coefficient 3 multiplied by our variable x plus a constant 4. That value will never change. That symbol will always mean 4 objects, and it's equal to 25 of something. All right? I don't know what x is, but that's what I'm trying to figure out here. What is the value of x that makes this side, the left-hand side, equal to the right-hand side? So, let's solve this equation. But I'm going to go ahead and I'm going to put the paper out front here because I'm not even going to touch that paper as we solve it this time around. What I've done is I've taken my Hershey's Kisses and my Skittles and I've made that equation just with candy. Okay? I've got my left-hand plate and my right-hand plate. These are exactly the same in value. We can imagine that they weigh the exact same amount, even though they look a little bit different. And in this case, every Hershey's Kiss represents an unknown, a variable, in this case, x. I don't know how much the value of a Hershey's Kiss is. Well, every Skittle is 1. It's a unit. So each Skittle is 1. And every Hershey's Kiss, well, I don't know how many Skittles each Hershey's Kiss is worth yet, but I have 3 Hershey's Kisses, 3x, plus 4 Skittles. That's my left-hand side. On the right-hand side, I have 25 Skittles. 3, 6, 9, 12, 15, 18, 21, 24. I'm glad I checked. 25 Skittles. Okay, I'm going to try to solve this equation. Now, one of the things that we probably know about equations already is that anything I do to one side of the equation, so if I take something off one plate, I have to take it off of the plate on the other side of the equation. That's just how it goes to keep it balanced. Equations are about balance. So, I'm going to look at my 2 plates and I think, well, I'm not going to be able to take Hershey's Kisses off of both of these, and I suppose I could divide the Hershey's Kisses up and split these, split all the Skittles up, but then I'm left with this like 1 Skittle here, and what do I do, chop it into 3 pieces? That doesn't make a lot of sense to do that, so I'm going to leave the 3 Hershey's Kisses and my 4 Skittles. Hey, wait a minute. I notice I've got Skittles here, Skittles here. What if I just take away these 4 Skittles? Take away those 4? That means I'm also going to have to take away 4 on this side just to make sure that the equation stays balanced. And now I only have Hershey's Kisses on this side, and I only have Skittles on that side. Perfect. I can divide these up. I'm going to take my Hershey's Kisses, I'm going to divide them up into 3 groups, because I have 3 Hershey's Kisses, and I'm going to take my Skittles, and I'm going to divide those into 3 even groups. Okay, I'm going to start by just estimating 4. Nope, I need to add more to each one. Add 2 more to each. Nope, going to have to add 1 more to each. Okay, I've got 3 equal groups of 7, which means that each Hershey's Kiss was equal to 7 Skittles. Okay, so I just solved that equation to figure out how many Skittles each Hershey's Kiss is worth without ever touching the paper. So let's take a look at how we might do that on paper and if it looks the same. So I have my equation, 3x plus 4 equals 25. So remember, at the beginning, I had 3 Hershey's Kisses and 4 Skittles on my left-hand plate, and then 25 Skittles on the right-hand plate. And I said, oh, I could get rid of Skittles on both sides. I'm going to get rid of 4 of these Skittles on the left, 4 Skittles on the right. So now, if I take away those 4 Skittles, I have 0 Skittles on the left. I'm only left over with 3 Hershey's Kisses. And on the right-hand side, I had 21 Skittles left over. Then I divided my Hershey's Kisses into 3 groups, and I divided my Skittles into 3 groups. Obviously, I have to do the same thing on both sides, which means that 1 Hershey's Kiss was equal to 7 Skittles, which is exactly what I found out with the candy. It was the exact same thing. I just solved the equation first with candy and second on paper. So let's look at another equation. All right, I'm going to put this one over to the side. Our second equation, it's going to look a little bit different here. I've got the equation 3x plus 8 equals x plus 14. Ooh, this one's a little different because I do see that there's a variable on both sides of the equation. So I'm going to get my plates back. There we go. 3x, that's going to be 3 Hershey's Kisses. Ooh, I'm going to need another Hershey's Kiss. And then I've got 3x plus 8. So I've got 8 Skittles, 3x plus 8. There, I'm all set to go. That's on the left-hand side. On the right-hand side, I have 1 Hershey's Kiss, and then 14 Skittles. All right, we're all set. I've got 3x plus 8 equals 3x plus 8 equals x plus 14. Let's solve this without ever touching the paper. Okay, in this case, I could do a couple things. I see that I have Skittles on both sides of the equation, so this one has less Skittles. I'm going to take these 8 Skittles off, which means I also have to take 8 Skittles off of the other side. 1, 2, 3, 4, 5, 6, 7, 8. Leaving me with 3x, or 3 Hershey's Kisses, is equal to 1 Hershey's Kiss and 6 Skittles. Again, I'm trying to figure out how much each Hershey's Kiss is worth in Skittles. All right, well, let's see. I have Hershey's Kisses left over, so I already got rid of Skittles. Now, wait a minute. I could take 1 Hershey's Kiss off here and 1 Hershey's Kiss off there, make it easier on myself. No, I have Hershey's Kisses on one side and Skittles on the other side. Perfect. So what I'm going to do is now, I'm going to take my Hershey's Kisses, divide them evenly, so I've got 2 groups. I'm going to take my Skittles, I'm going to divide those evenly. I now have 2 groups of Hershey's Kisses, 2 even groups of Skittles, and each Hershey's Kiss is worth 3 Skittles. So I just, again, solved that equation without ever touching the paper. So let's see, does it match up with how I would solve this equation on paper? So remember, what I did first, I had the equation 3x plus 8 equals x plus 14. I started by taking away 8 Skittles from each side of the equation, which left me with none on the left-hand side, just 3 Hershey's Kisses. And I was left with 1 Hershey's Kiss and 6 Skittles. But then I was like, well, I still have a Hershey's Kiss over here. I'm going to get rid of that Hershey's Kiss. And that's going to leave me with 2 Hershey's Kisses on the left and 6 Skittles on the right. I divided them into 2 even groups, and that left me with each Hershey's Kiss being worth 3 Skittles. Okay, now you might notice there's another equation at the bottom, the exact same one. That's because there's another way that we could solve this equation, and it's going to look a little bit different, but I think it's going to get us the exact same thing. So I'm going to reset this equation, and we're going to solve it again. We're just going to do it a different way. Last time, I got rid of the Skittles first, and this time, what happens if we get rid of the Hershey's Kisses first? Okay, so I've got Hershey's Kisses on both sides. I'm going to get rid of 1 on the right which means I have to get rid of one on the left. Okay, I only have Hershey's Kisses on this side. None over here. Now I can get rid of Skittles. I can get rid of these 8 Skittles, which means I'm going to have to get rid of 8 Skittles over here as well, leaving me with only 6 Skittles, 2 Hershey's Kisses. Again, and I can already tell this is going to be the same thing. Even though I got rid of Hershey's Kisses first this time, I divide my Hershey's Kisses up into 2 equal groups, Skittles into 2 equal groups. Each Hershey's Kiss is worth 3 Skittles. I did the same thing. So what would that look like on paper? Well, it would look like this. Last time, I got rid of my 8 Skittles first. This time, I got rid of a Hershey's Kiss first. I got rid of that 1 Hershey's Kiss, which meant I had none left over on the right, and only 2 left over on the left. 8 Skittles on the left, 14 still on the right. Then I got rid of those 8 Skittles, had to do that on both sides because I'm not going to knock the equation out of balance, which left me with 0 Skittles on the left, just 2 Hershey's Kisses, and 6 Skittles on the right. Again, I divided these into 2 equal groups on both sides, which meant that 1 Hershey's Kiss was equal to 3 Skittles. Look at, I just did that 2 completely different ways, but since I used the properties of equality that allow me to solve equations, I got the same thing both times. All right, let's try a really tricky one. This is the last equation we're going to be solving today. This one is 3 times the quantity, 2x plus 4, equals 24. Okay, this one's tricky because I have 3 times this quantity, 2x plus 4. What that means is I have 3 of the exact same thing. 3 of 2x plus 4. So in this case, I'm actually going to bring in my other plates. I'm going to need more plates for this one. I need 3 plates on this side, and they all have to be exactly the same. This coefficient says I have 3 of the exact same thing. 2x plus 4. So each plate has 2 Hershey's Kisses and 4 Skittles. 2 Hershey's Kisses, 4 Skittles, 2 Hershey's Kisses, 4 Skittles. So I have 3 of the exact same thing, 3 times the quantity, 2x plus 4. Now, the other side is just 24. So I've got 3, 6, 10, 14, 18, 20, 4. Okay, so now I have my equation set up. 3 times the quantity, 2x plus 4. I have the exact same thing on every plate, 3 sets of it. Can I solve this equation without ever touching the paper? Well, I could do a thing where like I take 4 off of this plate and take 4 off of this plate and then do the same thing with all the plates. That doesn't make much sense because then I'm leaving like plates with Hershey's Kisses all. I'm not going to do that. Well, what if I did this? What if I combined all of the Hershey's Kisses? I have 3 sets of 2 Hershey's Kisses, which means if I put those all together, I actually have 6 Hershey's Kisses. Okay, what if I took all of the Skittles and put them together? I have 3 sets of 4 Skittles, which means I have 12 Skittles. So all I had to do was multiply the number of plates times the number of Hershey's Kisses on each plate, which gave me 6. 3 plates times the 4 Skittles on each plate, which gives me 12. Now I'm going to solve it the exact same way as before. I don't have Hershey's Kisses over here, so I'm going to take away, well, the only thing I have to take away on both sides, which is 12 Skittles. There go the 12 Skittles. I'm going to take 12 Skittles away on this side as well. And that means that I'm left with 6 Hershey's Kisses and 12 Skittles. I'm going to divide them up into 6 equal groups. Just like I've done with all the others, I'm trying to figure out how many Skittles per Hershey's Kiss. Okay, we're kind of making a ratio here. All right, and that means every Hershey's Kiss matches up with 2 Skittles. So I know that each Hershey's Kiss is worth 2 Skittles. So let's see if the same thing can happen. Remember, it was Hershey's Kiss, 2 Skittles. Let's see if the same thing works when we do this on paper. So when we solved this with our candy, we said we had 3 sets of, and let's kind of think of this as a plate. Each plate had 2 Hershey's Kisses and 4 Skittles. We had 3 of those plates. Now, we combined them all together. We said, I want 3 sets of the Hershey's Kisses. I kind of put them together. So 3 sets of 2 Hershey's Kisses gives us 6 Hershey's Kisses, just like we had. 3 sets of 4 Skittles gives us 12 Skittles. And that's called the distributive property. You're probably familiar with that. But all we're saying is, well, if I have the same thing 3 times, well, how much do I have in all? Now I'm going to solve it. We got rid of our 12 Skittles on both sides, leaving none on the left. We just had those 6 Hershey's Kisses on the left and 12 Skittles on the right. Then we divided them into 6 equal groups, meaning that each Skittle was equal to, each Hershey's Kiss was equal to 2 Skittles, just like we did when we solved with the candy. All right? So really, all we did was we modeled this equation using candy and plates. So here's the real skill. Because you could, theoretically, just do these same equations over and over. You could record this video and just solve 3x plus 8 equals x plus 14 over and over again. That's going to get real boring real fast. So what I think you should do is learn how to make your own equations. You can make your own. You could have a friend make them for you, or a family member, or whoever. And then you can practice solving equations with candy on your own. The first thing you're going to need to do is you're going to need to figure out what's the value of each Hershey's Kiss. So 1 Hershey's Kiss, as I'm making my equation, each Hershey's Kiss, I'm going to say, is worth 2 Skittles. I'm kind of making the answer at the beginning. X is going to be 2. Each Hershey's Kiss is going to be worth 2 Skittles. All right, so let's say I have 3 Hershey's Kisses. Well, that's going to be 3x, and let's just toss a few Skittles on here. 4 Skittles. All right, 3x plus 4. Well, if x is 2, that means 2, 4, 6, 7, 8, 9, 10. I know that my total is going to be 10. All right? I just made an equation. And I could go through and I could solve this the exact same way I did before. 3x plus 4 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I could solve this equation using Hershey's Kisses and Skittles. Now, like I said before, you don't need to use Hershey's Kisses and Skittles. They could be anything you want them to be, as long as one thing represents an unknown quantity or a variable, and one of them represents a single unit, 1. If you do that, you can make any equation you want. You can make a game out of it. You can make the solve the equations with random household objects game and solve an equation never touching a paper. All right? So that's my challenge for you. I cannot wait to be back here and do this again next week with some more challenges. Until then, stay safe, everyone.
You've been watching Phoenix TV's Study Hall, brought to you by District 8 and our partners at Osborn and Roosevelt School Districts. Tune in Monday through Friday from 9 a.m. to 11 a.m. for more Study Hall. I hope you learned something today and keep up the great work.